Hello friends, in this AV we are going to talk about the combination of resistors in series. Now this is a very important topic for class 10 as well as for class 12 physics. Now in this series we see that we have three resistances which are connected in series with a battery which supplies a current of I. The value of the current is I. Now for series connection we just have to keep in mind that the same amount of current, that is I, will flow through all the three resistances R1, R2 and R3. So we have written, let R1, R2 and R3 be the three resistances that are connected in series and the current I flows through it. Now if we talk about the overall potential difference, then the overall potential difference of this circuit will be given by V is equal to IR, where I is the current and R is the overall resistance of these three resistors which are connected in series. Now let us mark this as equation 1. If we talk about the first resistance, then here the potential difference will be V1. So V1, the value of V1 will be IR1. Similarly, the potential difference across R2, that is V2, will be IR2. And the potential difference V3 across R3 will be IR3. As I told you in the beginning of this AV, that the current will be the same for all three resistances. The same current I will flow through R1, R2 and R3. So this is what we have, and in this case, that is in the series connection of resistors, the potential difference, the overall potential difference will be given as the potential sum of the individual potential differences, that is V is equal to V1 plus V2 plus V3. So putting the value of V, V1, V2, V3 in this final equation, we will get V is equal to IR, V1 is equal to IR1 plus V2 is equal to IR2 plus V3 is equal to IR3. So we find that I is common, so we can take I common from all three and we are left with R1 plus R2 plus R3. Now I and I cancel out and we have R is equal to R1 plus R2 plus R3. So we find that the overall resistance for a combination of various resistances in series will be nothing but their sums respectively, and the overall resistance of the circuit will be more than the value of the individual resistances. Now if there are n number of resistances, then the overall resistance for a series circuit will be given as R1 plus R2 plus R3 plus R4 up to Rn. Now this is a very important formula for numerical purpose, which we will be using in the next AV when we deal with the numericals based on the series combinations of the resistors. Thank you. God bless.